Okay, section 6.2b investigates the domain and range. And the domain is a set of all possible values for your independent variable, which is usually your x, and the range is a set of all possible values for your dependent variable, which is usually your y. So if we look at the graphs below, this is a little bit of review from 1201. You should be able to identify the domain and range like you did in Math 1201, grade 10 math. So now we've just got the direction of opening combined with it. So when you look at this one here, the direction of opening would obviously be down. The graph is opening down. And the domain, there is no x on the x-axis which does not have a matching point with that coordinate on the graph. So, because the graph keeps getting wider and wider and wider. So the domain would be all real numbers. And the range, though, you would need to look at the vertex. And because this one opens down, you're going to have basically, that's the highest y value that you're going to have is y equals the y coordinate of the vertex. Everything else is going to be below that. So it'd be y less than or equal to the y coordinate of the vertex, which is 3. The next one, the direction of opening is up. The domain is still all real numbers. That graph keeps getting wider. And the range would be, if you look at the y's, the lowest y, there's a minimum point on the graph, so the lowest y that gets used is y equals -4, and every other y that's used on that graph is a y value above -4. So that means y is greater than or equal to -4. The next one has a direction of opening which is up again. The domain is still all real numbers, but the range this time, the y coordinate is 1, and we have everything greater than or equal to 1. The next one, the opening is down, and the domain is all real numbers, and the range is everything from that y value of 4 is the highest, and everything else is less than that. So it's y less than or equal to 4. So what you notice about the domain was always all real numbers. And can you make a generalization about how to determine the range? You need to know if the graph opens up or down, basically, and what the y coordinate of the vertex is. So the equation for the range would be y greater than or equal to the y coordinate of the vertex. If the graph opens up, or it would be y less than or equal to the y coordinate of the vertex. If the graph opens down. So if we summarize those results from the last few days to see if you kind of put everything together, the graph of a quadratic is known as a parabola. Pen's not working again for some reason. Okay, parabola. And the graph of a quadratic is symmetrical about a vertical line known as the axis of symmetry. The equation for the axis of symmetry is x equals -b over 2a, or the x coordinate of the vertex. And if a is less than 0, the parabola opens down, and the vertex is a maximum point. And the y coordinate would be the maximum value. Because if they ask you for the maximum point, it's both coordinates of the vertex, but if they ask you for the maximum value, you only want the y coordinate of the vertex. If a is positive, the parabola opens up, and the vertex is a minimum point, and the y coordinate of the vertex is the minimum value of the function. The domain is always all real numbers unless you're told that x refers to time or something like that, where you might not have any negative values possible. But generally, if you're just given the quadratic equation in this form, or as an equation form, usually it's all real numbers. If the graph opens up, the range is y greater than or equal to the y coordinate of the vertex. And if it opens down, it's y less than or equal to the y coordinate of the vertex. So some practice questions now. So the first one here, if you're looking for the vertex, you're looking for the coordinates of this point right here, which is 3, -4. And the axis of symmetry then would be x equals the x coordinate of the vertex, which is 3. The domain would be all real numbers. And the range would be everything greater than or equal to the y coordinate of the vertex, which is -4. The second one here, your vertex would be -1, 5. Axis of symmetry would be x equals -1. The domain would be all real numbers. And the range would be everything less than or equal to +5. For the next two examples, you don't have a graph to look at, so you're going to have to use the algebraic method of finding the x-coordinate of the vertex using -b/2a. So first we'll start with that. So -b in this case would be -8/2 times the -2, which would be -8/-4 or +2. So then the y coordinate, you would just plug it back into the equation. And that would give you 4 times the -2 is -8, plus 16, plus 1, which is going to be 9. So the vertex would be 2, 9. And the axis of symmetry would be x equals 2. And the domain would be all real numbers. And the range, because this graph has a negative in the front, that means it's going to open down. And that means that the y coordinate of the vertex, the range would be y less than or equal to, because if it opens down, you're going to have a maximum and everything is going to be below that. So y is less than or equal to the y coordinate of the vertex, which is 9. And the next question, got a new equation, so then this time the -b/2a value would be the negative of -4/2 times 1, which would be, because if there's nothing in front of the x squared, is understood to be a 1. So that would be +4, negative of a negative would be positive. So that would be +4/2, which is 2. And then y, just plug in x is 2 into your equation, so x squared becomes 2 squared, minus 4 times x becomes 4 times 2, plus 8. So that gives you 4 minus 8 plus 8. And those 8s are going to cancel, and you're left with just 4. So the vertex would be 2, 4, and the axis of symmetry would be x equals 2, because you need the x coordinate of the vertex for the axis of symmetry again. And the domain again is all real numbers, and the range would be, in this case you've got a +1 understood in front of the x squared, so that means it opens up. So if it opens up, it's going to have a minimum, so the y's are going to be greater than or equal to the y coordinate of the vertex, which is 4. And there's some questions on page 332, 335 there for you to try for practice. Notice that you only got to do the domain and range for them, for these questions.